Okay, let's discuss the importance of Java. Almost most of the technologies are connected with code Java. Generally, the Android developers should know Java, and the software testing tool is called Selenium. It's another software testing tool. So to work in the tool, definitely need Java. So Java is playing vital role almost many technologies. So big data, you would have heard about that. Big data is a very big platform for handling huge volume of data. There we have many tools to support for handling big data. One among that is Hadoop framework. To work in the Hadoop framework, you need to know Java. And SAP, what I heard about that is an ERP. SAP. In the SAP web application, we actually require Java. Even in cloud computing also, to work in that environment, sometimes you should know Java to write in the scripts and all. And there is something called Salesforce. It's actually a CRM solution. Again, to work in that, you need Java. Still, to work in many modern tools and technologies, Java is essential. Okay, so if you want to become a Java developer, what you should know? First, you should know core Java. Okay, the core Java concepts first you should know, and then an advanced Java concepts and struts, Spring, web services, design pattern, Java, JSF they used to call. So these are all different. Uh, I mean, uh, these are all very important for learning Java and to become a Java developer. As of now, if you are familiar with core Java, that's enough. Later on, when you are started to work in a Java-based projects, once you get a job or something, and by that time, it's essential for you to learn all these advanced Java concepts. So Java is a core for many technology. Now, what you should know to complete core Java? Now I'm talking about the core Java. What you should know? So first, you should know the class elements. In any object-oriented programming language, uh, all the concepts, everything will be written inside the class. Those who already learned C++, oops, so you would know the importance of class. So the class having multiple elements, the elements like variable, methods, constructors, instance block, static block. So you should have practical knowledge about all these five elements. Okay. Java keywords. There are predefined keywords with some meaning. Okay, it's already defined in Java, and there are close to 50 keywords in Java practically. So I can show you the difference. For example, data types. When you take data types, primitive data types is byte, short, int, long, float, double, character, boolean. So this itself 8. And flow control statement, if, else, switch, case, default, break, for, do, while, continue. This is a 10. I'm just trying to justify what are the 50 keywords. It may be more now in the advanced features, but these 50 keywords are already in the Java, which we should use it for learning Java practically. And exception handling, try, catch, finally, throw, throws, and an object level. They used to call new keyword is an object for creating objects in Java. We will be using new keyword, and this super instance of these are all object level keywords. And methods means that while we are creating a method, you have to give either void or some name to the method, and definitely towards the end of the method you have to return something. So void return and source file like class, extends, interface, implements. Okay, and inheritance concepts and multiple inheritance and all, you'll be using this interface implements, package, import. These are all keywords with meaning. In the side, I mean, you can also notice the number of counts I have mentioned here. Modifiers, private, public, protected, final, static, abstract, synchronized, volatile, strict FP, native, and transient. These are all again the modifiers. And Java 5 is an advanced features. They're using enumeration and assert. And there is some reserved keywords which will not be used. Okay, but the reserved keyword like go to constant. So if you count this, it will be around 50. When you are familiar with all these keywords practically, then the learning of Java is good. Methods. See, methods used to write logic for the applications. Okay, you would have learned already. I mean, methods means I'm talking about the function. C is function, C++ function. Whereas in Java, they used to call it as a method. There are different types of method: instance method, static method, normal method, abstract method, and assessor methods. They will call getter setters. Okay, so these are all different types of methods. Again, overridden methods, overriding methods, final method, public method, private method, protected method, default method, synchronized method, non synchronized method. These are all different types of methods. So we have to practice with all these methods. Then you can get the familiarity. And Java classes, generally we'll be creating a class with a class name. No, there's a normal class. Apart from that, abstract class, final class, public class, default class, immutable class, mutable class. So these are all the elements you should be familiar. Okay, so the elements means variables. You should know about different types of variables, different methods, constructors, the instance block, static block. When you start learning about all these variables, methods, and what are the keywords, predefined keywords, and you should solve some examples based on that, then we can say that you have learned Java. You have some familiarity in Java. Still, there are a lot of things to learn. You have to do some competitive coding practices along with the data structures concept. That are all very important for cracking the interview in the product company and all. And after becoming the developer, also you should learn that advanced Java concepts. What I said, like struct, Spring, everything. And now we'll be discussing more about Java environment. So, what is Java environment? See, generally to work in Java, you have to install Java development kit in your PC or laptop. So the Java development kit will have Java runtime environment, Java compiler, and other development tools. And Java runtime environment will have JVM and some set of libraries. Okay, this is the hierarchy of this Java development kit. And you can see in this image, the Java development kit having development tools plus Java runtime environment. So when you are installing a Java development kit, you are installing the complete package actually required for developing Java applications. So there you will have JRE again with some development tools will be there. When you see only JRE, you can see JVM plus some libraries. That is Java runtime environment and Java virtual machine. So when you install JDK, completely you will get entire thing which are required for developing a Java application, running that application, and even deploying the application. Everything you will get. But in some situation, Java development kit completely not needed. Even if a Java runtime environment is there, there you can only run the Java code and JVM, Java Virtual Machine. That is very important. That plays a vital role in almost all the Java environment. So Java Development Kit is a bundle of software components. The software development, I mean, is a software development environment used for developing Java applications. It includes Java runtime environment, that is JRE, development tools like Java compiler, Java documentation, debugging, etc. And JDK is a complete package for any Java application development. We can run a code, we can execute code, we can launch the application as well. Okay, you can develop, run, execute, and launch the application. For that, JDK is a complete package. But Java runtime environment (JRE) is used only to run Java application. It includes JVM and core libraries. So the Java runtime environment will always have JVM plus set of libraries. To run any Java code, JRE is a minimum requirement. Okay, even if you're not developing a Java application, but you want to run the application which was developed by someone else, means definitely JRE is very very important for you. And inside the JRE, JVM is that plays a major role here. So JRE contains set of libraries and then JVM that used to run the code. JRE physically exists in your machine, okay, on your system, okay. So it's like a package; it will be installed. JRE is platform dependent. Each operating system requires its own JRE version. So the last video, when I was talking about the characteristics of Java, I told that Java is platform independent. Java is platform independent means the code which you are developing, the source code, once it is compiled, it is becoming a bytecode, that is dot class file. So that dot class file can be executed in any platform. The platform means the combination of the OS and the hardware. Okay, when you are developing in a Windows and an Intel combination platform, you're developing a code, but that code can be executed even in a MacBook, even in a Linux environment. That is what I told. The Java program, Java application is platform independent. So here I'm telling JRE is platform different. JRE means it's an environment where you're going to run our Java code. That particular JRE is platform dependent. For Windows OS and Intel, the JRE version will be different. Okay. Similarly, see here. For Windows, JRE contains Windows specific JVM libraries. Okay, so JRE is platform dependent means JVM also obviously going to be the platform dependent. For Windows JRE, a different JVM will be there. For Linux JRE, that is a different JRE will be there, like .dll files, .so files. For Mac OS JRE, that is a different JVM will be there. So JVM is platform dependent, but the Java application you are developing is platform independent. Please understand this point. JVM Java Virtual Machine is inside JRE. JVM is a program that runs on the OS in your system. It includes class loader, bytecode verifier, interpreter, JIT compiler, garbage collector. When you take a JVM, almost in all the systems you will have JVM. Definitely, because there are many applications around us. Whatever you are using, everything is having Java into it. Okay, even in a laptop, even in a mobile. Okay, while you're making some settings and all, no, by the time itself JVM will also be installed. Okay, many of you playing games which is actually developed by Java. So in order to run that game in your mobile or your PC, definitely JVM is required. So JVM will be there virtually in your system. Okay, so that JVM is actually platform dependent. I told, no, depends upon the platform. That specific JVM will be there, but the JVM is having the capacity to execute the code which is developed in some other platform. So it is platform independent. What the code is platform independent. The Java application is platform dependent, but JVM is platform dependent. Okay, so JVM having set of things like class loader, bytecode verifier, interpreter, JIT compiler, and garbage collector. This thing I already discussed in the characteristics of Java. Okay, so JVM creates a virtual runtime environment. Okay, inside the system. So what it provides during the execution of the code, Java code, it will provide a virtual memory. There is heap or stack memory and virtual CPU execution and a thread management, garbage collection. The garbage collection means once a variable or something is utilized after the execution of the code, the variable has to be destroyed. That is garbage collection. It has like a small computer running inside your computer. That is what JVM is. Okay, specific to Java applications. So JVM is also platform dependent. Obviously, when JR is platform dependent, JVM is present into that one, So JVM is also platform dependent. JVM is a software that directly interacts with the operating system and hardware. Okay. So every operating system works differently. Every CPU architecture works differently. So JVM must be written separately for each platform. So this is a key thing you should know. Okay, depends upon the platform. JVM is also configured and developed accordingly. So now any code developed in any platform can be executed in any platform. Okay, the reason is JVM. JVM. So how Java code actually runs? Please observe this clearly. See, when you are developing a Java code, that is any code, when you are developing a Java code, generally the extension you will use to save is .java. After after giving the name for the Java code, it will be .java. And after compilation, that particular .java code will be converted into a bytecode and it will be saved as .class file. Okay, so the bytecode is also called .class file. Okay, so after compilation, it will be into .class file. So the bytecode can understand by JVM, not the .java. That is the key here. So what is the necessity of compilation? After compilation, apart from checking the syntax errors and other data type compatibility and everything, it is converting that into the .class file, which is called bytecode, because JVM can understand only the bytecode. JVM can't understand .java extension. That is the first thing. So after compilation, it is converted into .class file. Now JVM having set of things I told no. JVM having things like class loader, bytecode verifier, interpreter I told no. Now what will happen? This .class file was handled by the JVM in your machine or any machine. So it will be sent to the class loader. So class loader is actually part of the JVM only that loads this bytecode into the memory. Okay. Now there will be a bytecode verifier which will check the loaded bytecode in the memory. Okay, it will check whether it is valid one. It had suppose it is a malware or something, it will be eliminated immediately. Okay, that's why Java is secure because bytecode verifier is responsible for checking the bytecode. Okay, which was which we want to execute. So bytecode verifier is keenly checking everything. So we can say Java is secure because of this purpose. And interpreter, that interpreter reads the bytecode stream then execute the program. So interpreter, compiler, okay, both are closely similar. Okay, in in many programming language, some programming language will have compiler like C++, they're using compiler, whereas in Python it is interpreter. End of the day, how it works, compiler compile the entire code, at last will give the errors, what are the errors in which line, which part of the code. Interpreter, it will check line by line. Whenever an error occurs, it will stop there and it will get notifications given to you. Once you rectify the error, then just check the next set of the lines. So line by line execution, line by line checking. That is what interpreter is playing here. So in Java only we have both compiler and interpreter. Only for compiling purpose, converting into the bytecode purpose, we're using compiler. For running, you're using interpreter. Okay. So interpreter now after bytecode verify the bytecode, it is going to run the code, and it is going to convert that code line by line into the machine understandable language, that is machine code. Okay, so and finally the program is executed. So this is what happened actually. Now you have to observe one thing in this diagram, that compile time. Compile time means a normal Java code is compiled and converted into .class file, which can be understandable by the JVM. Okay. Now when it is moved to the JVM having set of things like class loader, which will load that particular .class file into the memory, and then a bytecode verifier will come into the picture and will check the .class files authenticity, like whether it is a malware or any virus or it is a normal code or something. It will check that, and then it is given to the interpreter. Interpreter is also like a compiler. It will convert that particular code into a machine understandable code, and then the process is going to execute the code. Okay, this is what JRE environment. This is what JDK. Okay, so the JDK is handling the compile time part, and the JRE is handling this runtime part. Okay, so during code execution, JVM together with some libraries and JRE helps to code running. So with this, I just conclude this importance of Java and how a Java environment will actually work. Thank you.